10.1, we are going to be working on a goodness of fit test. It is a chi-square test, and it's used to test whether a sample frequency distribution fits an expected distribution. So we'd be checking to see if a sample would match up with like a previous study. So we're checking between observed and expected values. Okay, let's just go to the steps and then we'll work through an example. So the first step is to verify that the observed frequencies, those are the ones like if you take a survey. So observed frequencies, the counts of your surveys, were obtained from a random sample and each expected frequency is at least 5. The expected frequency comes from a previously stated distribution. We'll see it in our example. Step 2 is identify the claim, and we're going to state H sub 0 and H sub A. Now there's really very little wiggle room for H sub 0 and H sub A. H sub 0 is going to be that the frequency distribution fits an expected distribution. It's going to be phrased in terms of the problem, as you'll see when we do our example. So it's not going to literally say that. It's going to say something in the words of the problem that you're working on. And then H sub A, the alternative hypothesis, is that the frequency distribution does not fit an expected distribution. In step 3, we're going to specify the level of significance alpha, and degrees of freedom, which is going to be k minus 1. Now k in this case is the number of categories in your distribution. Then we're going to use these to sketch the rejection region. The rejection region is going to be based on chi-square distribution. So when we draw that, remember the chi-square is the funky looking one. What we're going to have over here is that this area is going to be alpha, and this is going to be our chi-square value. This is going to be our rejection region. And there's no guesswork on which type of test it is. It is always a right-tailed test. Next, we're going to find the test statistic. And it's a chi-square value. It's chi-squared equals the sum of this big fraction. I'm going to tell you what these letters are in a minute. It's O minus E squared divided by E. So O is the observed frequency. of a category in the sample data. E is the expected frequency or calculated frequency if it's calculated, then the way you calculate it is by taking n times p. N is the sample size, and p is the assumed probability of the category. Then next we're going to make our decision. Based on that rejection region, and interpret the decision in the context of the claim. Okay, so we're going to do this example here. In exercise, well, we're going to follow these instructions. We're going to identify the expected distribution, state the h sub 0, h sub a, find the critical values, rejection region, chi-square test statistic, decide whether to reject or fail to reject, and interpret the decision. So basically all of those steps that I just pointed out to you. So let's take this a bit at a time. The pie chart shows the distribution of opinions of U.S. parents on whether a college education is worth the expense. So this shows the distribution of opinions, and that's all of this stuff. All of that stuff is related to h sub 0. That's our expected distribution. Then we have this economist comes along and claims that the distribution of the opinions of U.S. teenagers is different from the distribution of U.S. parents. So there's our claim that the distribution is different from the expected distribution. So h sub 0, remember, h sub 0 is the frequency distribution fits the expected distribution. H sub a is the frequency distribution does not fit the expected distribution. So this claim right here has to be h sub a because h sub a is the one that doesn't fit. So our null hypothesis is that the distribution of the opinions of U.S. parents on whether a college education, so it's the h sub 0 is going to say that the frequency distribution fits an expected distribution. So it's going to say that the distribution of the opinions of U.S. teens, is the same as the U.S. parents. In other words, that .4% strongly disagree, 6% strongly agree, somewhat, gosh darn it, somewhat disagree, 5% neither agree nor disagree, 30% somewhat agree, and 55% strongly agree. That a college education is worth the expense. So let's kind of break that down a little bit. The null hypothesis is that the distribution, the claim says that the distribution of the opinions of U.S. teenagers is different from U.S. parents. And so what we're saying in H sub 0 is that the distribution of U.S. teens is the same as U.S. parents, meaning that 4% strongly disagree, 6% somewhat disagree, 5% neither agree nor disagree, 30% somewhat agree, and 55% strongly agree that a college education is worth the expense. So then H sub A, which is going to be the claim, is that the distribution of opinions of U.S. teens differs from the expected distribution. So we're not going to restate all of that, and we're also not going to say what we think the distribution is. We're just going to say that we're claiming it's different. So to test this claim, what you do is you randomly select 200 U.S. teenagers. So to test this claim, you randomly select 200 U.S. teenagers and ask each of them about their college, if they think college education is worth the expense. The table shows the results. So here's our results from asking our 200 teens about college expenses. And we're testing this at alpha equals 0.05. So let's go through our steps here. Verify the observed frequencies are from a random sample, which they were, and each expected frequency is at least 5. Well, our expected frequency we're going to calculate in just one moment. Identify the claim that the frequency distribution fits the expected, so the teens fit the expected distribution. H sub A, that it does not fit, so we said it does not fit. And then we're going to draw our little right-tailed test here. We know that the level of significance alpha is 0.05, and K is the number of categories. So we have 1, 2, 3, 4, 5 categories. So our degrees of freedom, we've got alpha is 0.05. Our degrees of freedom is K minus 1. 1, 2, 3, 4, 5. So we have 4 degrees of freedom. Remember that these are always going to be right-tailed test. So here's going to be our rejection region. We need our chi-square charts. Right here. Alpha is 0.05, which is going to be over here, and degrees of freedom, I already forgot, was 4. So our critical value is 9.488. And we are on to find our test statistic. So in order to do this test statistic, we need to know what O is and what E is. O is the observed frequency of a category in the sample data. So our observed frequencies for each of the categories comes from our sample data. Strongly agree we had 86, somewhat agree we had 62, neither agree nor disagree was 34, somewhat disagree was 14, and strongly disagree was 4. Now our expected values are going to come from the expected distribution here, and we're going to have to calculate those because these are percents. So what we do to calculate our frequency is take our sample size, which was the 200 teens who were surveyed, times the assumed probability of the category. So for our expected values, in the strongly agree, we'll take our sample size of 200 times the 55% that we would expect to have strongly agree, and our expected value there is going to be 110. And then we do the same for the 62 and somewhat agree, which was at 30% here. That gives us 60. And then neither agree nor disagree would be 200 times 5%, which is 10. And somewhat disagree was 6%, 200 times 0.06, which is 12. And then strongly disagree was 4%, so 200 times 0.04 is 8. Now this is what our original verify said. We have to verify that each expected frequency is at least 5. So here's our expected frequencies, and you can see that all of them are at least 5. Now to find the value of chi-squared, we are going to add up O minus E squared divide by E. So we're adding up a bunch of these little fractions. What I've found it's easiest to do rather than make a table is just to add them up, like go along this way. So we just take O minus E squared. So 86 was O, minus 110 was E, square that, and divide by E, which was 110. And I just do that for all of these pieces of data. So then I do O minus E, so 62 minus 60 squared divided by E, which was 60, plus 34 minus 10 squared divided by 10, plus 14 minus 12 squared divided by 12, plus 4 minus 8 squared divided by 8. Then I just do all of those in my calculator and add them up. So 86 minus 110, whoops. Carefully do them in your calculator. So 5.236, I'll just go out that far, 5.2364. 62 minus 60 squared divided by 60 plus 0.0667 plus 34 minus 10 is 24, so 24 squared divided by 10, 57.6 plus 14 minus 12 is 2, 2 squared is 4, 4 divided by 12.3333 plus 4 minus 8 is negative 4, squared is 16, divided by 8 is 2. So I add up all of these values, 5.2364 plus 0.0667 plus 57.6 plus 0.3333 plus 2, and I get 65.2364. Now that chi-square value is way out there. So when I place that on my distribution, 65.2364, that is way in the rejection region. So we are going to reject H sub 0. And since H sub A was our claim and we're rejecting H sub 0, we're going to say that there is enough evidence to support the claim. So we would say that at the 5% level of significance, there is enough evidence to support the claim that the distribution of opinions of teens differs from the expected distribution.